In this episode, we are going to investigate the shrink ray from the Despicable Me 1 movie. First, let's watch 2 video clips from the movie. Question: is it possible to shrink the moon to the size of a baseball? Before that, let's take a look at the info regarding the shrink ray gun from Wiki.
Here you go. Interesting, huh? Here's some notable facts. As noted by Dr.Nefario, the effect is temporary, and the time it takes for the object to be restored is inversely proportional to its size, which is known as the Nefario principle. Here it says the duration an object takes to be restored is depending on its mass. Thus, this implied that the time taken to be restored is inversely proportional to the mass of the object being shrunk. Next, we need to clarify scientifically by what means does the shrink imply. Here's some ways that I can think of to achieve shrinking. A. Reducing the mass and volume simultaneously. B. Shrinking by means of compressing. To find out which one does it depicts in the movie, we must recall the moment when the moon is shrunk. I think it is reasonable to assume that it is method A. Let's recall our physics lesson. Since the tide disappeared, the gravitational pull from the moon ceases to exist, or its mass has decreased dramatically to a negligible value. Hence, we can make an assumption that the mass of the moon together with its volume is decreased simultaneously to achieve shrinking. Okay, so far so good. What if it is method B? By means of compression it will be so much different. The mass of the moon will remain unchanged, while the volume changed. Since the mass didn't change at all and assume that the distance between the center of the 2 celestial bodies remain the same, there's no change in gravitational pull, and the tides still exist. However, the volume decreased to about the size of a baseball. The density, also read as rho in Greek letter, has increased. But, will the density of the moon increase so much that it collapsed into a black hole and punctured the space-time fabric? According to the Schwarzschild radius formula given by the following, any object with a physical radius smaller than its Schwarzschild radius will be a black hole. The standard diameter for a baseball is about 7.3 centimeters. The radius would be 3.65 centimeters. By taking all those value and constants, and we get 1.08964 times 10 to the power of negative 4 meters. Therefore, it is not small enough to become a black hole. Up next, how does it shrink? I will be using an analogy of syringe. Remember, the object will restore to its default size after some time. This is similar to compress air inside a syringe, where the air inside has the tendency to push back to regain its original volume. But this is regarding to pressure, and governs by gas law. So, how can we do it like in real life? In Einstein's mass-energy equivalence principle, it is said that mass and energy is equivalent, and is convertible. Suppose the mass of the moon is reduced to that of a baseball. Using the formula of mass-energy equivalence, the change in mass is 7.347 times 10 to the power of 22 kilograms.
The mass of the baseball is negligible.
The energy released in order to reduce to the mass and size of a baseball is equal to 6.612 times 10 to the power of 39 joules. energy released is approximately equivalent to 300,000,000,000,000,000,000,000,000,000,000,000,000,000 times more powerful than the most powerful bomb ever detonated. The Tsar Bomba. I don't think Rue will survive. And how did the object restore to its original size? By absorbing this enormous amount of energy from the universe to restore to its default mass and size. Or store them in some kind of reservoir first and retrieve them when restoring.
I don't think so. Ridiculous.
Okay, thanks for watching.